Okay, so welcome to all my friends. We'll be starting the introduction to programming in Python session that is primarily meant as an introduction to people who are new to programming or people who are from a non-technical background. So just introducing myself, you all know me. Just myself, Arun Pierre. I am working in ISRO and I have experience in C++, C, Java, and maybe 1 year experience in Python. So we can go to the material. So I'll be covering these points maybe like in 2 sessions with a break in between. So first session we can cover maybe till simple Python function. So we will see why you need to program, setting up the environment, Python basics, and a simple Python function we can see. And then we can break because maybe we can take a break for 5 minutes and we can proceed with the last 3 points. And between, if you have any doubts, you can interrupt and ask at any point. So we can go ahead. So first thing that we will see is why you need to program. So basically, as you can see, everything that we see about this, we are using in this WebEx environment for this meeting. So what is this built upon? It is basically a program. So a program, something that is running in the WebEx servers, is providing us access so that we can sit in our homes and chat with each other over the internet. So this is what basically a program is there sitting in the background which is doing this. So now if we go to data science, we have lots of data. So we need to do something with data like extract, transform, load, which is commonly called ETL logic or something to make it suitable for us to process it. So that step involves a set of programming, which we usually use in Python. Then we need something to store that data, which we use if it is SQL or something, we will use a small database. Or if the database is big enough, we will use a big table or another big database technologies. So all this also requires a programming in the background. And finally, we need to make use of this data for which we will write a machine learning algorithm or some other algorithmic application or use TensorFlow, PyTorch, things like that. So that also will require a knowledge of programming. So if we see specifically to the data science. Now we'll just tell a specific use case. So as you can see here, you can see me in the video. Okay, I think you can just see how the video is being streamed. So in that you can see the background. You may think that this is the actual background, but that is not the case. The actual background which is there sitting in which I am sitting is this, right? So basically this is my actual background. So if I move, okay, my hand, you can see me waving my hand, but then what you are seeing is like some other thing. So this is basically an AI based application which WebEx is using. So they will be like taking my image and they will be finding, like if I move my hands, you can see the gaps in between, which is the algorithm which is trying to sync with the changes which is happening. If I use my direct image, that much this disturbance will not be there. But this AI based background which I am using will be having a what time in lag in getting it to process my input. So that is a simple application of a AI based programming, which is basically image processing application. We have different types of programming languages. I have put a link which you can go through later. I will be sharing this notebook. So this basically I will just tell like we have machines usually understand 0 or 1, right? We can understand English, Hindi, whatever languages or mother tongues, but a computer can understand it everything in only message of zeros and ones, and that is called a machine language. But for us to directly instruct a computer to do 0, 1, 0, 1, that thing is like not possible for us in the every day. As the program grows more complex, for simple programs, we may be able to do that. But if the program goes more complex, it will not be possible. So we go for one step higher, it is called assembly language. So assembly language, we will write like move some value to some register, copy this value from this register to the register, but that is also still near to the machine. So then we have some low level languages, middle level languages, high level languages. So low level languages like are one step higher. High level languages are the highest thing that is more similar to English. So our CPP, Java, Python and all come in this high level languages. So that we can write in near to English way to get our things done. Now that will be each of these languages will be having something that is called syntax and semantics. So that is syntax is something that you need to follow how to write the code. You need to like put an assignment, you need to put like x equal to 10. So that is like part of the syntax. Then there's something called semantics that you can refer to. So these are like therefore each language these things will differ. So then we need to see why we are going for Python. Since you are mostly from non-technical background, Python is one of the easiest languages which can be learned on by a beginner. So that is as you might have already realized when you see simple programs in Python and all. CPP or Java, some 5-6 lines code you can write in Python in one line, or even in other ways. If you have some very big programs, making use of the Python libraries that other people have developed and released as open source, we can implement whatever algorithms we want in minimal lines of code. So, as a beginner point of view for data science related application, Python is very much preferred all over the world. And there are competitors also, but okay, Python is the most suited for beginners to start the data science learning. So you can go through the link when you get time. So we can proceed with our thing. I think you already have installed Anaconda in your environment in your PCs. So that comes pre-built with all the modules and libraries that may be required to develop your data science applications. And some things you may need to install later, but that you can always refer to Google or something. So I have put the Anaconda installation direct instructions here, so you can go through. And I am currently running whatever your screen you are seeing is from my VirtualBox. So I have a Windows PC. So I don't want to disturb the default settings in Windows. So I install something that is called a VirtualBox that will run on top of my Windows. And in VirtualBox, I can install whatever OS I want, be it Mac OS or Windows or again Linux. I am this one is running is Ubuntu. So in Ubuntu, I am running Anaconda so that my actual Windows nothing is there other than the default things that come with the Windows installation. So the advantage of this is once I make this virtual box, then if I am needed to do this application in some other PC, I can just copy the virtual hard disk, which may be some 5 GB 6 GB file from this PC, and put it in the other PC. So I need not set up anything there. I just need to install VirtualBox here. So once I have a running hard disk image, so every time I can use that. So I need not like install again and again. So that much I hope basics you have already done. So we will go to the basics. So I'll be covering as basics three things mainly. Python variables, data types in Python, and Python keywords. So basically this is for every language you'll be having things like this: variables, data types, keywords. And but when you go through most of the lectures, these are the basic things which help you to write a program. So somebody already familiar with some of the languages may take this for granted. Uh, so okay, one message we got like what are libraries? So libraries are basically a set of Python code that somebody else has developed that will be suited or tailored for a particular application. For example, I need to capture an image from a camera. So for that, I need not write a code from scratch to capture the image from camera. Somebody else would have already released that as a free Python library that you will have to take the help of Google or something to find which that library is. So like that, you can always, for whatever application you want, most of the time, you will be Python open source libraries will be available. And your job might be like clubbing these and writing the interface between these libraries so that you are actually building a pipeline from input to output, and you put your library functions in between so that you get whatever desired outputs you want. And somebody had put a message like they are not able to hear. I hope it is settled now. Anyway, don't worry, I will be putting this video in YouTube, so you can always later go ahead and refer to it, as well as the notebook I will share in GitHub. So we will see variables, data types, and keywords. So what is a variable? So I have just written here x equal to 1, y equal to a, z equal to 2. So variable is basically something that tells a programming language, what I should call a memory location. So basically, I am storing everything in memory. So it may be some location 1000, 2000, like in that the memory. So from a programmer's point of view, I need not know at what memory location it is getting stored. So I'll be naming the memory locations by a user-friendly names, which I will be assigning. So XY that I have put, but the best practice is you put what names that describe for what function you are using that as a variable name. So here you can see 3 lines: x equal to 1, y equal to a, z equal to true. So all these are like assignments. So I have one thing you can notice is that next data types when I go, you can be more clear. Unlike in C++, Java and all, the variable names here and the variable types here are not assigned during when I am writing the code. It is assigned dynamically when the code is being executed. So that if I write x equal to 1, y equal to a, z equal to true again, then the final type will be x will be of integer numeric type, y will be of string type, and z will be of Boolean type. So one thing is, again, if I again write x equal to false, then the type of x will change from numeric to Boolean. So that way, dynamic data types changes are possible in Python. And one more thing, that the difference that I can tell between other programming languages, there are many languages like Python in that. So it is basically an interpreted language. So basically, you need not compile anything. You just write your code in a script, and there will be something called a Python interpreter. So which is what is running the taking your inputs and running the Python code. So this is if you take consider Java. So Java is having like 2 steps. You need to compile the code, then it will generate something called a bytecode. That bytecode you run in a Java runtime environment, so that finally you get the output in JR. If you consider even C++, it has the other step of compilation, linking, things like that. Finally, machine code is generated, and actually applications will run in the native OS format. So compared to that, the easiest one is Python, because you need not worry about any of those steps. You just write your code and the interpreter will do the rest. That whatever compiling interpreter will do, and it will convert it to machine code native. For example, I am running this Python in a Jupyter notebook, running in a PC for running Windows. So basically, I am Anaconda running in Ubuntu, running in Windows XP, Windows 10. So that way it will be handled. So now, okay, we will proceed further. Okay, so basically we will be seeing the data types in Python first. So what is a data type? So I am telling the Python interpreter that, like if you see in this slide, I am telling it that x equal to 1, y equal to a, z equal to true. Then the Python needs to know what is the type of this value I am referring to. So that next I will say maybe x plus y. Then it should understand that, okay, I need to do something which is clubbing an integer or a string, or I am telling a plus b and I am passing 1 and 2. Then it needs to understand that I am passing 2 integers 1 and 2, and you need to add it and give me the result. So for that is the purpose of a data type. So how Python knows the data types? Normally in C++, Java or some other languages, we will statically assign the types. That is, when we write program itself, the type of variables are fixed. But Python, the dynamic allocation is followed. That is, when I am assigning value to a variable only, the type of the variable is fixed. So we will just see what are the different types of data types in Python, and we will see the examples for each of these. And there, if some things are related to this, I will just highlight at that point. So basically, we have a string type like y equal to a here. So that will be, the Python interpreter will take that as a string type. So the keyword for that is str. Then numeric types, int, float, and complex are supported in Python. So for all our numbers 1, 2, 3, 0, -1, -2, it will like x equal to 1 here, it will default to a integer type. And if I give 1.0, 2.0, 3.0, or minus, then e raised to 10, something like that, that will be counted as a floating point number by the interpreter. Next is the complex ones. If you remember your plus 2 maths things, you might have learned complex numbers 1 plus 2j, 3 plus 5j, and addition, subtraction, multiplication of those things in maths. So those are basically our complex numbers. So if I give you like with how we are defining that, I will come to. So that will be treated as a complex numbers. Then we have sequence types, which are like list, tuple, and range. So how we will define each of these, I will tell. But what it is and all, you can get to know through the other materials. I will just give how you can identify which one of these data types are you talking about when you write a line of code or when you see a line of code. In mapping type, we have a dictionary. Set types, we have set and frozen set. So this is also similar to our plus 2 maths, we have learned sets. So there it supports union, intersection of sets. So those kind of things will come in this set type. Boolean is the default 0 1 logic. That will be true or false. So here anything that defaults to 0 will be taken as false, and all non-zero values will be taken as true. So if I use a Boolean condition on int, 0 will be false, anything else will be true. Float 0.0 will be false, anything else will be true. Like that. Then binary types, bytes, byte array, memory view are there. These are like advanced things. But only thing that you need to know is just to define how these things. So I'll just give an example for that. So here I have put reference to Python default documentation. So here in very detail, all these things are covered. You can go through. I will just tell how you can find the type of each and the example for each. So suppose you give this command, print type of within single characters A. So this is a command which will ask the Python interpreter to assign a variable to the value A and print the type of that variable. So what will be the output? I think for these things you can just put in the chat what you think will come out of these data types. So I have put examples. So you can just put in chat what will be the output of these commands. And I will be running the parallel. So as you might have already guessed, this is a string type. So you will get output as a class string. So, and next I am having type of 1. So I have just put a number 1. So as you might have already guessed, it is an numeric type, which is an integer. So that it will Python interpreter will return as class int. Suppose I give similarly I have examples for float and complex. So float you will like if you have 1.1, 2.2 things like that, it will come as float. And like complex numbers, we will be defining like this: 2 plus 8j, or even 0 plus 8j, 2 plus 5j, things like that. So that will be automatically, dynamically assigned to the type complex. And suppose coming to list, if I put within square brackets any comma separated values, that will come as a list. Now the advantage of list is, like unlike it is similar to arrays in C++, Java and all, but here the list can be heterogeneous. Like I can put a integer, float, complex number, string, everything together in a list. So this is acceptable in Python, whereas in languages like Java, CPP and all, the heterogeneous arrays are not supported by default. You will have to do additional things like use the polymorphism feature in C++, etc. But Python by default, having data of different types in your list is supported by default. Then after list, what we will see is a tuple. Tuple is also similar to a list, but the thing is that a list is mutable, whereas a tuple is immutable. So what do you mean by this? Mutable means that you are able to change it dynamically while executing the program. Whereas immutable means that once you assign a value to that particular thing, you are not allowed to change that further in the steps. You can only use that similar to a constant. So that is what is called a immutable type. So tuple is an immutable type, whereas list is a mutable type. Then my next line, okay, that is like a quiz for you. So you can just predict what is the output of this. Like I have put similar to tuple, I have put inside this normal braces, brackets, say 1, and I am trying to print the type of that. So you guys, can anyone guess what will be the output of this? Okay, I'm not seeing any replies. Okay, so you can just make a guess. Will it be tuple? You can type yes or no. Okay. Okay, anyway, I will execute. You can just see what it thinks and see where it matches your prediction or not. So like it comes as int. So why it is? Because when you go further into programming, you will learn like arithmetic operators, operator precedence and all. So basically, suppose we have a big operation running on integers, we will need like 1 plus 2 into 5 plus 3 into 5, things like that. We will need to put this inside brackets. So if you define a single integer value inside a brackets, the Python compiler or Python interpreter will think that maybe you may be using that for some arithmetic operation. So it will take that as an int only. But suppose if you are having two values inside a tuple, that it will take as a proper tuple. So why this can come is this can come in programming interviews, or even if you are writing MCQ questions, this thing is something that is a favorite. Like what will be the type if you put define similar to a tuple a single value. So that will now suppose I give value here a string value. So that also it will come as a string type and not as a tuple. But most people will maybe give the answer as tuple. But whereas in this case it is not that. Then the next sequence type is range. So that range is used to make when we need an iteration from 1 to 5 or 0, 2, 4, 6 like that. I can make use of the range command. You can go through the link I have given, that is having the details of all these commands and all the functions that these are supporting. Now we can see an example of a dictionary. So dictionaries are like basically key value pairs. So I have a key, then value 2. So suppose I have more key values, then I can give that also in my dictionary. So the next thing we will see is like a set. A set, as you can see, both uses curly braces, but dictionary uses a key value pairs. So you are telling that if I call dictionary key with key 1, that will return 2. If I call a dictionary with key 3, it will return 4. And whereas a set will have a set of unique elements and it has a single elements. If you see the difference from a dictionary. Then true, you might have already guessed it is Boolean. Whereas last I told like some advanced things like bytes, byte array. So there if you have thing like bytes, it is similar to string, but you will have a b before the variable constant name, string name. So that will the compiler will interpreter will take that as a byte. So this types, and now we will just see keywords. So now I told earlier that Python variables we need to give names. So what is allowed as variable names? So anything is allowed except Python keywords. Well, that is true of any language. C++ you cannot use Python keywords as variable names. And there are some restrictions like you may or may not be able to use numbers, underscore, special characters as your first character. For example, C you can put underscore as a first character, but numbers cannot not allowed. In Python, numbers is not allowed as first character of a variable. So when you give a variable name, it should not be a keyword and it should follow the Python semantics. So that is it should start with a letter like uppercase or lowercase or a mix. You can go whatever way you want. So I'll just tell the main keywords. Maybe there are around 35 keywords. You can get a list of keywords in Python with the help keywords command. So basically we will just separate it into types and then see that. So basically values we have, as we saw in bool, true, false and none. The operator like by Boolean operators and or not in is. Okay, I'm just giving telling you to make this familiar with these terms. We will see examples for a few of these later. So control flow keywords, if, else. So with that you can implement your conditions in your code. Like if some statement is true, do this. Else if something else is true, do this. And if nothing else matches, do something. Iteration is like you need to repeat something a particular number of times, you will use a for loop. And if you need to repeat something maybe indefinitely or you don't know how many times you need to run that, you will use a while loop. And the break and continue are used to control the iterations. Like a break will like exit the iteration, and continue will like skip the current iteration. So iteration is basically like you are doing something in a loop. You are repeatedly doing something. And here else is also there, like what to do when the whatever while condition you are given, once it comes out of that, you need to something that you can put in an else. And there are structure keywords defines def, which is used to define functions, class keyword which is used to define class, then with, which is used to like when you want to open a file, so you can write like open file, or along with that you can use with. And as an alias you can call like import some matplot library as pyplot, so that is like as. And pass is like if a function you don't want to do anything, you just want to return, you will give a pass. And lambda functions are like functions for which you need not give any type or name. You can define it like inline functions. And return keywords, you when you are returning from a function, you can give return or yield. So basically the difference is that return is like every time you will be returning a value, or whatever value is computed, whereas yield is like a generator kind of concept, where you only return from the function value for the current loop. So if I called a function again and again with yield, so if my data is like 1 billion entries are there in my data, if I use return, my program will most probably hang at that point, because it will have to process everything and then only give me the data back. For in such purposes, I will be using the yield statement, which will be functioning as a generator. So that will like return, if I am asking for 10 values first, that will give 10 values. Then again, I will use yield to give the next 10 values. Like that, I can iterate over the billion values before without overloading my process. And import keywords are used to, as we told earlier, we are making use of libraries developed by others, and they will be releasing it as open source things. So in that case, we have to like import the library into our code. So for that, we will use import this particular library name or function name from which library we want. And if we want to like import some particular function from matplotlib as pyplot, that kind of way. And exception handling is like how you handle the error cases in your code. So you suppose you have a try. So try is like if whatever you put inside a try block, if some error happens in that try block, it will not raise, it will raise an exception, and with an except call, we can like gracefully handle. Normally, if you write C++ code or something, it will like crash. Or if you use a try catch there, you can catch errors that come during execution. These are usually used to deal with the runtime exceptions. So suppose I will show you in an example a runtime exception. So things like that you can handle using the try and exceptions. Raise is used to raise exceptions. That is, you yourself can check for particular input conditions and raise exceptions. And finally is used to like what to do after the try and except. Like when you finally return from that try except module, what to do. And else and assert similarly are there. Assert I will be telling in a short while. And other things are like advanced things we need not bother now. So we will be more or less this first 7 or 8 type of keywords. We will be more or less seeing in almost all the programs that we write, and we will be like dealing with them, and we can see details about them in future sessions also. So I'll just show you a simple Python function, right? So this is a basic definition of a Python function. So here what I am doing, I am defining a function. So I have used the def, define keyword. So I'm defining a function by the name add, or I can have anything here. I can have add numbers, add strings. So I will tell you why I did not put that here. So later. So add is my function name. So what am I giving to the function? I am giving it two variables, a and b. So then I have to tell what it is supposed to do with that variables. So for that, once you define the function, you have to put a colon, and the next line of function body should be like intended. So if I am having a function, it should be either 4 spaces or 1 tab. Jupyter is okay with both. But if you go to some script file or something, you will have to follow the same convention throughout. If one line you cannot put like 4 spaces and another line tab, it may throw you an error. But Jupyter takes both. So this is my function definition. So once I run that, I have already defined to my Python interpreter that I am having a function a and b, and the function has to return me a plus b. So I have not, as you can see, I have not told here what type of value or what is the type of data. So I will just try this with multiple types of data and see what is output. So suppose I have two numbers, 1 and 2, and I call this function add with those two numbers. So what will be the output? I think you guys can be a bit more proactive, or for each of the lines, you guys can type in the chat window what you think will be the output of these lines, right? So add 1, 2. So what do you think this thing will return? So okay, this you can see from the code itself that it is supposed to return a plus b, and anything should work with numbers, right? So 1 plus 2 will basically return 3, the sum of these two numbers. Then suppose I give two floating point numbers, 1.2 and 2.2. Then also it should behave like that only, right? So as you can see here, this particular function that I have defined takes integer as well as float as input types, and it has no like objection in doing whatever I told. Now suppose I have one float and one int. So then also, as you can see, it will like give me the output. Like it will, because integer as well as float are numeric types, it will automatically handle the type conversion. And now suppose I want to do a complex number. So again, all the numeric types. So I have not, as we already told, dynamic typecasting is done in for variables in Python. So I have not defined it to for any particular type of data, whether it is int or string or something. But I can see that all the three numeric types, integer, float, as well as complex, have been handled by this. But sometimes this may not be something that you want. Sometimes you may want your function to do processing only with int data, or you want to enforce that you want to work only with complex data. Then you will need to add additional conditions using our if else elif statements that we saw earlier, or even with the type. We can see we can put a function value here, check here, like if type of a not equal to int, then you can delete or return a throw an exception. So things like that can be done. So now for the time being, I want it to work on all types of data. So I am just trying whatever data types I saw earlier, whether it will work on all of those. So next I will see two strings. So as you can see, I have passed two strings A and Z, and it has given me a concatenated string which consists of A and Z. Now if I have A, B, C, D here, then also like these are like two strings. So it will again give me the concatenated output correspond to these two strings. So a function like this, as you can see, you can do string concatenation also with a function like this. Now the next thing that we will be seeing is the next type is Boolean. So now what will happen? False and false. So now what? It is not returning false or true, right? So I have written A plus B. So the Python interpreter will see that, as I told earlier, false will be taken as 0. And true will be taken as 1 by default. But any non-zero value if you give, that will be taken as true. Now suppose I give true here and I add a true and false, I will get 1. So because by default interpreter, if it is giving value, it will give value of 1. Then if I give true and true, it will give us 2. So basically what happens here is, for the Boolean type, this particular function a plus b that we defined will convert that to integer type and then return me a result as an integer. So this is the first time that we are seeing that the input data type of the function is not same as the output data type. If again I cast the output to a Boolean variable, then again I will get it as a true or false. So but other than that, there is a type change from Boolean to integer. Now I have two lists, 1, 2, 3, which are the contents of the first list, and 4, 5, 6 is the content of the second list. Now I call this Okay. I hope you guys are comfortable with the pace. Should I slow it down a bit or explain it in more detail? Or anyway, I'll be providing the recording so that you can go through it again, and the notebook also you can try it out. So I got one message like maybe you can be a bit slower. Okay, so we can just be a bit slow. So here I have put two lists. The first list has the values 1, 2, 3, and the second list has the values 4, 5, 6. So now again I am calling our add function with these two lists. So what should be the result? Okay, one thing options I will give, like one can be like 1 plus 4 will be the first entry, 2 plus 5 will be the first entry, 3 plus 6 will be the third entry. Will it behave like that? Or like string what we did, it can like concatenate it into a bigger list having entries 1, 2, 3, 4, 5, 6. So we'll just run it and see. So as you can see, the add function that we have written here has basically concatenated the two lists as input. So this is what the add operation on a list will look like. It will lead to a concatenation of lists. Now again, similar to that, I have two tuples. First one is having entries 1, 2, and second one is having entries 2, 3. So now suppose I will again use our good old add function to run with this. And same as previous list, it will append the contents of the second list to the first list, and finally I will get a tuple, and finally I will get a tuple which has the data combined from both tuples. Now we have other data types. So next one is set and dictionary. So what do you think will come like when you add two sets? Like I have a set 1, 2, 3 and a set 3, 4, 5. So this can come like a multiple choice questions in your interviews or exams. So what do you expect is the answer here? So one option can be like similar to list and tuple. You will get a uh, set which contains 1, 2, 4, 5, removing the redundant 3. Or you may get an option like which will add 1 and 3 as the first element, 2 and 4 as second element, 3 and 5 as the third element. So those can be the action options. And we want what the final answer, what you can expect is this will actually lead to a type error, because as I told earlier, the set is like we have learned in plus 2, I think set is like supports union, intersection and all. So similar to that in Python, so addition operation is plus operator is not defined for a type set. So if you want to something like whatever use case we told, I need to use a set union. Python has keywords union, intersection, or I have to use an ampersand operator or operator, pipe operator to implement the operation that I want with the set. So as we saw, the add function that we wanted to run on all data types has failed in the when the type is set. Similarly, now we can see what it will happen when I use it to add two dicts. So ideally, my options will be like to get a new dictionary which will have two key value pairs. First key value pair is 1, 2, and second key value pair is 2, 3. That is what I would expect normally. But again, here as you can see, I will be getting a type error here because for the dictionary type also, the plus operator is not defined. So here also dictionary, if you want to make a bigger dictionary, you need to do a assignment of key value pair, but a operation like plus is not supported. So this thing can be like an MCQ question, like I had a function, so I run it on different types of data, and what will be the output. So basic takeaway from this is that for set and dictionary, this kind of arithmetic operators like plus, minus and all will not work. For our other types of data like numerical operators in float complex and our string, list, tuple and all, this will lead correctly. Now let me add some more complexity to this. So basically we are seeing the basics. So we will not make it too complex. So I will just ask. Now currently I am operating based on what? The value which I am directly hard coding. So now suppose I want to take some value from the user. So I put like input. So input is the uh, Python function which will take a value from the standard input. So I am giving a prompt to the user, enter first entry for addition. And second entry I am giving as, so this will be my A and B in the earlier case. There I am asking input, enter second entry for addition. So now we will see how this will come in action. So I am running. So my interpreter is asking me what entry I want first. So I will tell I want 23. Then second I will enter, I want again 12. So what we are expecting, I have entered 23 and 12. So my output should be 23 plus 12, that is 35, right? So, but as you see, that is not what I am getting. So why is it that? As you can see the type here, these are enclosed in single quotes. So you can infer that the type is string. So from this itself, you would have got the idea, because when I am reading the input will be read always as a string. So I have not specified any particular type to the add function. So as part of dynamic allocation, the type will be assigned to a string. So basically I will be adding a string called 23 and a string called 12. So that will lead to, as we saw earlier, a string concatenation, and as a result I get 2312, a string which is like concatenation of the two values that entered. Now what I want, I actually wanted to add 23 and 2. So then what I should do? I should like tell the Python interpreter explicitly that I want to take this input as an integer type. So for that, I have to again typecast it using a int keyword. Now let's see the same thing. I have just added, compared to the previous line, I have just added two ints here. So when we run this, again I will enter the same inputs 23 and 12. So as you can see here, we got 35, which is what we expected, right? So now we saw a function, right? So now I will tell you, basically you need to run a program, right? So I will tell you different ways in which you can run a Python program. So one way is like you can use a Python terminal. Like Python terminal, I can show you one. So I am opening a terminal. So you have to type Python 3, right? Because I am using Python 3. So you get a like a prompt where you can enter whatever commands you want. So I am telling a is equal to 2. Then same command that we tried earlier, print type of a. And I am getting a same output that I got in Jupyter, right? So then I can give another input, b equal to type string as a, and then I am again typing print type of b. Okay, so now as you can see, I have used a here, I have used a here, but both are not the same. The left hand side is the variable. So there's a variable called a, which I have assigned a numeric value to. And there is another variable b of type string, which I have assigned a string called a. So now again, now if I print a plus b, again as you can see, it will show that type error, unsupported operand types, because an integer and string addition is not supported. Now what I want to do, if I want to that to go through, I want to append those two as a string. Then I can typecast a as a string, because currently it is in numeric type. I am typecasting that to a string, and then I am concatenating it with b. So then I will get output as 2a, which is a concatenation. So, but the problem with this is you can write single line codes like this. So, but suppose you have a bigger programs, or you want multiple loops, iterations and all, this thing is tedious, like and it is difficult to do in this. You can do it, but it is difficult to do in this. And a similar thing you can get online also, from even Python shell, from Python to official site, or there are other people providing the same thing. So what we can do if my code is like a bigger or I have a loops or something. So I will keep this. So I had like prepared a. The second option is like executing a Python script. So that also same online or offline option exists. So I will just show you the. I have a function called a file called function.py. If you want it to see as a function, as you are familiar with in Windows, I open it in a text file. So I have defined a function in a file. It is called function.py, and in that I have defined our function definition: add a b, return a plus b, or same old function that we defined saw in Jupyter Notebook. So now I have already defined the function. Then I have a script I will show. I have some other file. So in that, like keywords that we saw earlier. So that I will just show. So basically my folder structure is so if you see here, I am having in this documents directory a file called script.py, and in that I am having another folder called folder, and inside folder I have defined this function.py, which contains the add function. So basically I have given this example such that when we have bigger scripts or when you have assignments to submit or something, you may be required to split your function or code across multiple files. So that's why I have chosen a simple example where you are using two files. So my first file I have the def add a plus b, which will give output return a plus b. Now I have a second file script which will import the add function. So the keywords you might be remembering. So I'm telling like my path. So from folder dot function. So this, what is this folder? That is the folder name inside which I am having this particular function.py file. As you can hear, this function.py here I am having inside the folder which is named as folder. So I will name my file as folder.function. So what I want to import, I want to just import the add function. If I have multiple functions defined in that, I will use a star here so that it will import everything what is there in that file. So I am importing that. Then I am just printing a statement hello world. Then I am asking your name, and then printing it as hello world followed by your name. And then again I am printing add one. So I am having a just basic script that all of this you are earlier covered in the earlier examples. So I will see how we can run the scripts. So what I have to do is again same Python 3 script.py I have to call. So if you are using Windows, same way when you give like here, I will just you can just try in your home button. So there you can type Python 3, then your Python 3 terminal will come. There you can give the file name, or you can do in the Windows command prompt also, or even Anaconda prompt. So I am in Linux. If you are doing, you will be doing like this. So I am entering my name, Arun. Then it will show hello world Arun, and we had given 1 and 2 as input, so it will print the output as 3. So this is one way to run a program, and this is one of the best ways. If your code runs into like hundreds or thousands of lines of code and you have it split across multiple files, then the third option is using an IDE. So IDE is basically an integrated development environment. So basically some IDEs come pre-installed with the Anaconda. So we can see Anaconda Navigator. So that in that there are some default IDs like Spider, and or you can install IDs like PyCharm. So in that whatever that folder import, that naming of files, all those things that I manually did in the earlier process that I show will be automatically done by the ID. So as you can see here, it has Jupyter Lab, which is what Jupyter Notebook, which is what we are currently using. A Jupyter Lab is like a Jupyter Notebook plus a file browser, things like that. and you have a Qt console, Spider. These things you can use as a GUI, which comes installed by default. Or even if you want, you can go for other Orange 3, PyCharm and all. That things you will have to need to install. So I'll be just launching RStudio, oh no, Spider, and we can just see our same example in that. I'll just show how we can, how different it is from running it from a terminal. So basically an IDE like makes the job easier for us. Like you need not like keep track of the files. Okay. So you have a temporary script file. So I'll just put a print line here, print hello world. Okay. So you have like a similar to earlier terminal that you saw, you have a Python console here where I can type a equal to 5, things like that. Right. Whatever I typed in Python, similar things I can do here also. And I have like a variable objects, all the objects, and like you can just navigate through the spider and see like if I have multiple variables, I will have a variable inspector also. So with that I can see during execution of program what are the values that a variable is taking. So if I run this, so it will ask where it wants to execute. So I can keep the default settings and I will give run. So as you can see, it will run file the temp.py and it gives me the output hello world. So same script.py and function.py that we implemented earlier, we can implement in a similar way in IDE also, but this way we will not be needed to handle the like file structure and all. The IDE will take care. So IDE basically makes the life easier for a developers. So I'll be closing that. So you can explore the IDEs on your own. And if you have any doubts, we are always there to help. So I am closing Navigator as well. Then the last way that I want to see is the Jupyter notebooks, which is what we are currently doing. So the advantage of Jupyter notebooks is that like conventionally we would make PowerPoint presentations. But now since we are taking like a programming class, we can have the data or presentation material as well as the code, everything combined in a like a simple notebook, what we are writing by hand. We are having a notebook here which we can share, which we can run again, which we can verify, or even if you have some assignments or something for some codes, you can submit it as a Jupyter notebook, or even directly you can generate the scripts output from this. So that way. But the problem is if your code runs into multiple files, hundreds or thousands of lines, then the second or third method only you should follow. If your code is manageable like within some 100 lines of code, then and then the Jupyter Notebook is ideal for code as well as documentation. If your code runs into hundreds of lines of code, which you may be required if you are doing some main projects, then your code may be large. So in that case, you go for this options 2 and 3 for your code, and you use this Jupyter Notebook for documentation, or even along with the inline code, there are other things like PyDocs and all, which will allow you to write your documentation along with the code. So then we will wind up in another 10 minutes. And so basically I will just tell you class concept and the unit testing basics. So we will not go through detailed examples and all. I'll just give you some basics to get started. So I have given some links here. You can go through that to get more idea. So basically a class concept is like what? The near world implementation of something that we have. So basically there are some concepts like encapsulation, abstraction, inheritance, polymorphism, things like that, jargons. You just keep these four. These four are called the pillars of object-oriented programming. So you can go through, get a more idea about these things in the two documents that I have provided. And then suppose I had our A plus B code. Then suppose I want to test the code. So I will have like a testing code. So I will just put a code to test. So suppose we need to have some assignments where they will be giving some test cases. So you need to tell that it meets their test cases. So we need to test the code. So one way is that you manually give, as we saw earlier when we were checking the add function, we can manually give each input and see. But the better ideal Pythonic way is that you use an unit test and you can define a function, and then you can define functions inside that to test. Okay, this you can just take it as a backbone. This thing you can build upon. I'll just run it and see, or tell you what the output means. So I have a test case here. So I am adding 2 and 2 and I am asserting equal. So I am checking whether that is equal to 4. Okay, then I am assert almost equal. So that means Python has defined it at some 7 decimal points or something. I am adding 2 and 2 and I am checking whether it is almost equal to 3.99. Similarly, I am having a function test add assert not equal, where I am adding 2 and 2 and I am checking whether it is not almost equal to 4.01 and assert not equal. So there I am checking 2 plus 5 and I am telling that check whether it is not equal to 5. So we will see what is the output in each of these cases. So it will tell that my test add assert equal failed. Why it failed? Because I have given almost equal to as 3.99, but I got output 4. I am asking it to check with 3.99. That is not same within 7 places. Now suppose I give 7 places here, 3.9, 5, 6, 7, 8, some addition steps here. Then that will also pass. So you understood the difference, right? So this is one thing that you can basically use to test the code that you write. So basically with that we will wind up.